All right, good afternoon, grade sevens. I hope that you guys are doing well and that you've had a productive Wednesday so far. We're back again now for week 13 of classes. We've got some more work to get through, unsurprisingly. Um, I'm going to explain what we're going to be discussing today quite soon. I just want to give everybody a chance to quickly hop onto the live session and join us for today's class. But we are going to get started quite soon. While you are waiting for us to get going, please make sure that you have your stationery nearby and a way to take notes. Your stationery must include a calculator, please, guys. Okay, that's really important. And then I just have one favor to ask of you guys. If you guys could please type your name into the comment box, I would really appreciate it. And please keep in mind that you are more than welcome to ask questions at any point during today's lesson. You don't have to ask at a specific time. You're more than welcome to just type a message into the comment box whenever something's on your mind. And then as soon as I see it, I will respond to it. Okay. I have my eye on the comment box on both Facebook and on YouTube, so it doesn't matter where you're watching from. I will be able to see your comments. All right. But, guys, we've got quite a lot to get through today, so I'm not going to spend too much time waiting for everybody else. I'm going to give them maybe one more minute to quickly hop on. But you guys should be able to see my screen now on your screen, and I'm scribbling in different colored pens. You should be able to see white, yellow, orange, and even green as well. So let's just have a quick chat about what we want to discuss in today's lesson so that you guys know what's going to be happening. Last week we had our first session on Facebook and on YouTube at the same time. So first things first, please remember that if you want to watch recordings, you guys can find them on either Facebook or on YouTube, and they are completely free for you guys to access. Okay, it's not limited to one platform or the other. Now, in terms of the work that we want to cover today, last week we did quite a lot of theory, and we quickly discussed what the world of measurements really entails. Now, I spoke to you guys and told you that measurement is going to be quite an important topic, especially as we head into high school, and that's completely true. So we discussed what perimeter, area, surface area, and volume all are, and we touched on what their symbols are and the units of measurement that we have to use when we're working with each of those different forms of measurement. Now, in today's lesson, we're still talking about measurement, guys, because it is a pretty big topic. So we're going to be discussing area still, but we want to dive into some of the more complicated questions. These are the sorts of things you can probably expect to be running into in high school. And next week, we're going to chat about surface area and volume in one lesson, hopefully. And then we will be done with the topic of measurement. Okay, because I give you guys a lot of the theory up front and I show you some really important examples, the rest of the work is up to you. Right? You need to sit and go through practice examples on your own to make sure that you understand all of the work well enough that you can complete it in a test setting without getting overly nervous or anxious. So let's go ahead and start by writing down today's date, which is the 16th of April, and our heading is going to be area of parallelograms. Actually, there's more to it than that. Sorry, guys. Triangles. We're going to quickly brush over triangles. We're going to mention parallelograms. And compound shapes. So we're discussing pretty much everything else there is to do with area in today's lesson. So I am going to move at a relatively quick pace. If you guys need me to slow down so that you can copy, or you have questions, you guys know how to get my attention. You just have to type a message into the comment box for me. All right. So we're going to be talking about a lot to do with area. We're going to discuss 2 or 3 shapes, and then we're going to dive into some examples. Now, because these examples that I'm going to do with you today are quite intense, we might only get through 3 examples or so, right? And the reason why I'm taking it slowly is so that I can explain to you guys how we approach the questions, so that when you need to practice them on your own, you already know what to do. It's just a matter of using the correct numbers, okay, and practicing your layouts or format. So let's get going with today's work. I want to start by reminding you of a few of the area formulas. So the area of a square or a rectangle, excuse me, is very simple. You guys know that it's simply length times width. Now, some teachers will also say that it's length times breadth. Okay. You can technically use this grade 7s, but I would strongly suggest you use the first version. Then we're going to quickly touch on the area of triangles today as well. And we know, or you will see shortly, that the area of a triangle is a half times the base. And that's why I suggest using length times width, right? Because we like to use the letter B for base instead of breadth. The area of a triangle is a half times base times perpendicular height. Right. Let's quickly take a look at the world of triangles, grade 7s. You guys should have a basic understanding of this, but I am going to touch on today in any case. Right. What's interesting about the area of triangles, guys, very quickly, is that we get different variations. Okay, so we're going to talk about the area of 3 different triangles today. And then once we know how to do that, we'll tackle parallelograms and compound shapes as well. Okay. Right. So these are sort of the 3 kinds of triangles that we want to focus on in today's lesson. And I'm going to run through this pretty quickly because it is something that you guys should be familiar with, right? You should know how to calculate the area of a triangle. You guys can quickly copy these down, and I'm going to give you a little bit of extra information that you guys might not have discussed in class. First things first, guys, we know that the area of a triangle is a half times the base times the perpendicular height. We're going to discuss that first and apply it to some examples. Okay, we'll do these 3. So you can copy these down. I'm going to add some measurements to them. Okay, when we are talking about the area of a triangle, the first thing that you guys need to understand is that because there are so many different variations of triangles, we need to be able to correctly identify the base and the perpendicular height of a triangle. Okay? So, these are our three examples that we're going to quickly run through in today's lesson. And I want to talk to you about the area formula first. Sometimes you will see it written with dots like this, a dot written at a middle height, so not like a full stop, but slightly lifted off the line, means we are multiplying, right? So if you see the area formula written with dots as opposed to multiplication signs, they mean the same thing. Now, when we're calculating the area of a triangle, like I said to you, because there are so many variations, we have to be able to correctly identify both the base and the height. Now, a lot of students are a little bit confused by this symbol over here. This symbol that we see stands for perpendicular. Grade 7s, if you don't know this already, perpendicular means that it forms a perfect 90-degree angle. In other words, it's either perfectly horizontal or perfectly vertical. Now, if we're talking about a height, a perpendicular height, a height obviously means that we need a perfectly vertical line, right? Because height means up and down. So, when we look at triangles, and I'm going to start with the first example over here on the left, we have what we call an equilateral triangle, where all three sides of the triangle are equal in length. I want you guys to please highlight this on your examples or use some kind of colored pen, because this is the difference between you understanding this section and not understanding it. On the right over here, the yellow line that I have highlighted is often confused with the height of a triangle. This is what we call the slanted height of a triangle, right? The line that's sitting at an angle to form the incline of a triangle. But the orange line that I've highlighted over here in the center of the triangle is what we call the perpendicular height. Right? And that's important because when we look at the area formula for triangles, we want the perpendicular height, not the slanted height. And there is a good reason for us to have both kinds of heights. We will take a look at where we use slanted heights at a later stage. But for right now, we're interested in this perpendicular height that I've highlighted in orange. How do I know that it's perpendicular? Because it forms a perfect 90 degrees with the base of my triangle. It is perfectly vertical, right? It doesn't have to be vertical. It can be the case that we have a triangle that's sitting skew and our height sits like this, right, on one of the sides of our triangles. But what's important is that it forms that 90 degrees. It cannot be sitting at an angle with the base, right? That's the first most important distinction that we have to understand. So, when we start with calculating the area of the triangle on the left-hand side, we always begin by saying that the area of a triangle is equal to half times the base times the perpendicular height. Now, in any triangle, you're always going to have three elements. The base of the triangle, okay, and if you want, you can write this down somewhere on the side. I'm going to move this later on. But we have the base of the triangle, we have the height of the triangle. In this case, we're talking about the perpendicular height. And you also have the peak of your triangle, right? The top of the triangle. So if we look at this triangle on the left-hand side over here, we can see that the peak of my triangle is sitting right at the top over here. Now, sometimes it's a bit tricky to identify what the base is because our triangles are rotated, right? They might be sitting at a funny angle, but what we need to keep in mind is that the height is always going to connect the peak of your triangle and the base of your triangle. So if I know that this is my peak, I then also know that across the bottom over here, I have the base of my triangle. And the perfectly perpendicular line that connects those 2 points is considered my height. So when I go to substitute into my equation, we have a half times. The length of my base is 6 centimeters across the bottom of my triangle. And keep in mind, the bottom does not mean that it's the base. All right? What about my perpendicular height? It is not the slanted height. It's the 5 centimeters that we see on the dotted line heading up the middle of the triangle. When I go to simplify this, you guys can chuck this straight into your calculator, but I prefer to do it in steps. 6 times 5 is going to give me 30. And centimeter times centimeter is going to give me those centimeter squareds that I need to have in my answer. A half of 30 is simply 15. So the area of this triangle is 15 square centimeters, grade 7s. Okay. Now, if we try and take a look at our second triangle, again, we always begin by stating that our area is a half times base times the perpendicular height of that triangle. So in this case, we leave the half as is. Now, what is the base of this triangle? Again, we can see the peak of the triangle is over here. And the base is running across the bottom. How do I know that? Because it's connected by this height in the middle of the triangle. Not one of the sides of the triangle that we call the slanted height, but the perpendicular height running down the middle. So the base in this case is 160 millimeters. And my height is 50 millimeters. Again, you can do this in steps, or you can do it in your calculator in one go, as long as you remember what the correct units need to be. We can start with the numbers. 160 multiplied by 50 is going to give us 8,000. And millimeters times millimeters gives us millimeters squared. So when we times that by a half, you see that we get 4,000. But don't forget that you are working in millimeters squared. There is the area of your second triangle. Now, finally, the third triangle that we see over here on the right is the one that catches a lot of students out, where there is an external height on the triangle, right? Let's identify why we have to measure outside of the triangle in order to find the height. If we look at triangle number 3, okay, yes, we're going to start with area is equal to a half times the base times the perpendicular height. Now, how do I know what the base and the height of my triangle are? Well, I said that we always have 3 components, and the first one that we can spot is the peak of my triangle, right? The tippy top. Now, the base in this case, right, is this bottom line over here, our 8 meters. So why can I not just draw a line through the center of my triangle over here and call this my height? Well, remember, we said what's most important to remember is that your height is always going to connect the base of your triangle and the peak. If we draw a line down the center of the triangle like this, it doesn't touch the peak of the triangle, right? And so for that reason, we need to go to the outside of the triangle so that we find a line that is both in line with the base and it can reach the peak of the triangle. So here on the outside, we have the height of our triangle. All right. So when we go to calculate the area of this triangle, it's a half times. The base is only this line on the triangle over here. It does not include this section over here that I've highlighted in red. This is not a part of the base. It's not a part of the triangle at all. It's simply a line that we have extended so that we can find the correct height for this triangle. Okay, so our base is going to be 8 meters, no longer, and the perpendicular height is going to be the 6 meters that we find on the outside of the triangle. Again, you can choose to calculate this how you like, but work in steps. 8 times 6 is going to give us 48. Meters times meters is going to give us meters squared, which is why area is measured in squared units. A half of 48 is simply 24 square meters. Okay, why would we work in meters? Maybe this triangle is in someone's backyard and they're trying to calculate the size of a top that they want to hang for shade. Maybe they want a triangle swimming pool, who knows? All right, but these are the 3 variations of triangles that you guys need to be aware of. I'm not going to spend more time going through triangles. This is it. So make sure that you copy down everything that you need to very quickly, and please make any extra notes that you want to now as well. You must be able to identify the base and the height, the perpendicular height, correctly. Otherwise, you stand a chance of finding the wrong answer. Now, I'm going to move on to some more examples after this. We're going to go and take a look at parallelograms very quickly and trapeziums, which are technically compound shapes depending on how you want to look at it. I see that someone says that they've never learned this before, but they're taking notes. Guys, I would strongly suggest you take notes, okay? This is something that you guys should know by grade 7 level. Okay, maybe you guys are still going to learn this in term 3. That's very possible, but you should already know the basics. All right. So I'm glad if some of you aren't 100% aware of all of this, because that's what the point of these lessons is. All right. If you have any questions, guys, please type them into the comment box now. But if you understand everything that I've explained so far, please just type the word happy into the comment box for me. Okay. I don't ask a lot of you guys during these lessons, but it really helps me when you let me know if you understand it or not. So if you have questions, type it into the comment box. If you're happy and you understand, just type the word happy, please. This is not algebra, guys. This belongs to a section called measurement. Okay, it's how we measure the perimeter, area, and volume of different shapes. Keep in mind, guys, I do have a sneaky suspicion that there are 2 or 3 people that might be new here. So just very quickly, number one, welcome to you guys. I am very happy to have you guys here. In case you guys are not aware, these lessons are hosted on Facebook and on YouTube, but we only started streaming on YouTube as of last week. So you can go and watch last week's lesson recording if you'd like to, where we spoke about this topic of measurement from a zoomed out standpoint. But if you need recordings that are older than that, then you're more than welcome to go back on Facebook to go and find the lessons that you want to watch. Okay. So now that we are done talking about triangles, I'm going to move down. If you guys need some extra time to calculate, to copy, you're going to have to just ask me to come back to this at the end of the lesson. All right. So the next thing I want to quickly touch on is what we call compound shapes. What in the world are compound shapes, guys? I want to write a definition because it's going to help you understand why we break things up as we do our next examples. So quickly write down a definition. A compound shape which is usually irregular is a shape that can be broken down into many regular shapes. Like squares, rectangles, and triangles, which is exactly why we covered those first, grade 7s. Squares, rectangles, and triangles. There are more, and eventually you guys will learn about circles too. We are not focused on the area of circles just yet. You guys will learn about that soon enough. For now, we are focused on squares, rectangles, and triangles. All right. Someone says that next week they're going to be writing a test on algebra. Guys, I do want to just point out that a lot of you guys are going to be tested on different topics at the same time, right? So maybe some of you will be doing algebra while others will be doing maybe measurement like this, or some other topics like patterns and sequences. And unfortunately, I'm not going to be able to go over everything with you guys. But if you have one or two specific questions, you're more than welcome to ask me at the end of the lesson, and I'll try and help you quickly. All right. So when we talk about compound shapes, guys, what are some examples of compound shapes? Well, let's say I take something simple like a rectangle, and all of a sudden I see that we are combining it with triangles. Okay, just give me 1 second to quickly get this right, please, guys. Okay, I'm not going to spend too much time perfecting these shapes because I don't want to waste your time. But a compound shape, guys, like the definition says, is an irregular shape, meaning that it's not something we maybe see in everyday life, but it is something that can be broken down into regular shapes, squares, rectangles, and triangles. Okay? So for example, over here, this is what we would call a compound shape. Why? Because it's not a shape that we specifically have an area formula for, right? I wouldn't even know what we would call this specific shape, but there is no area formula. So because there are millions of different shapes that we can make, It's impossible for us to go and study the formula for every single possible shape. Instead, I can choose to view this shape over here as a triangle plus a rectangle plus another triangle, right? And when we talk about compound shapes and we need to calculate their area, it's very important that we practice breaking shapes up into smaller, more recognizable shapes that we can work with. So let's go ahead and calculate the area of this shape over here. I'm going to add some measurements onto this very quickly, and I'll make it slightly bigger so that you guys can see. I would suggest you quickly copy this down if you can. Otherwise, you will always be able to come back to the recording and copy later on. Let's say we are measuring in centimeters. Right. This is our shape that we are given, and we are asked to calculate the area of this shape. First things first, break your shape up into pieces so that you have shapes that you already know how to deal with. We already spoke about having a triangle over here on the left-hand side and another one on the right-hand side. And in this case, guys, these triangles are identical in size. Right, there's an 8, a 5, and a 5 on the same sides of the shape. But then you also have a rectangle that you can calculate separately, which runs through the center of the shape. So while we might not have an area formula for whatever we would call this shape, we can break it up into smaller pieces. Now, although that seems simple, the reason it becomes tricky is because students don't know how to properly lay out their work. So that's what we're going to talk about now quickly. If I'm trying to calculate the area of this entire shape, let's start at the very beginning. We know that area is equal to A, and if I wanted the total area of this shape, how would I find it? I would need the area of a triangle plus the area of my second triangle plus the area of the rectangle. I'm color coding my work so that it's easy for you guys to follow. You do not need to do the same thing if you don't want to. Just make sure that you label everything clearly in that case. So this is what we want to work towards, grade 7s, the area of a triangle plus the rectangle. But we need to obviously calculate these values. So let's start with the easiest part. The area of a rectangle is equal to the length of that rectangle multiplied by its width. Looking at the rectangle that we see in the center over here, the rectangle is 15 centimeters long, so we fill that into length's place, and it must be multiplied by the width, which is 8 centimeters. 15 times 8 is going to give us 120, and centimeter times centimeter gives us centimeters squared. So without realizing it, there's already the first piece of the puzzle done. We have the area of the rectangle, but we also need the area of these triangles. Now, if you are sitting in a test or an exam, take a second to just check if the triangles are the same size or if they are different sizes. In this case, they are the same, so we only need to calculate it once. The area of a triangle is a half times the base times the perpendicular height. You always start by stating your formula. Looking at our triangles over here, it's not so easy to identify which side is the base, right? But we can see that we have the peaks of the triangle on either end. And usually opposite your peak is your base. So in this case, these lines over here would be considered the base of our triangles. And conveniently for us, we were given the height straight from the base to the peak. Remember, this is what we call the perpendicular height because it forms a perfect 90 degrees. So our base is 8 centimeters and the height is this 4 centimeters running through the center of the triangle. It is not this slanted height that we see on either side, which has a length of 5 centimeters. So we keep the half. The base of our triangle, we've already agreed, is 8 centimeters, and the perpendicular height is 4 centimeters. These are calculations we've already been through, and they're very simple once you have correctly identified the base and the height. 8 times 4 is going to give us 32. And centimeter times centimeter gives us centimeters squared. Half of 32 is going to give us 16. So we know that the area of one triangle is 16 square centimeters. Now, at this point, we do not have the final answer, right? This is still part of the working out. We were not asked for pieces of the calculation or parts of the area. We were asked for the final area, okay? And that's exactly where this little bit of information that we wrote down at the beginning comes into play. The total area of my shape is equal to the area of one triangle plus a second triangle plus the rectangle. So we can go and fill these values in now that we've calculated them. The area of a triangle is 16 centimeters squared, right? So we're going to have 16 centimeters squared plus another 16 centimeters squared because our triangles are the same. Finally, our rectangle is 120 centimeters squared, so we make sure to write that down as well. And you can go ahead and put this into your calculator and see that you get an answer of 152 centimeters squared. And what this does for us grade sixes is allows us to calculate the area of really weird shapes, even if we don't have a formula for it yet. Okay, now keep in mind, a calculation like this would probably get 2 marks for the area of a rectangle. You would probably get 3 marks for the area of a triangle, and you'd likely get 2 more marks for your final answer. So you're looking at around 7 marks for a question like this. And so your teacher isn't going to give you 5 of these in a test. They're just going to give you 1 because it's a convenient way for them to test many things at the same time, right? We can test the area of rectangles, the area of triangles, the area of compound shapes, and just your ability to break shapes up and work with the numbers that you've been given. So these kinds of questions are great for teachers because it's an easy way to test a lot in one question as opposed to having 5 separate questions on each thing. All right. If you have any questions about this example, please quickly type a message into the comment box for me. Now, I see that someone said here that the last time we had a lesson, I asked you guys to type messages into the comment box for me if you specifically wanted lessons for other subjects. And I just want to quickly take a second while you guys are copying to explain this in a little bit more depth. Guys, for right now, iRainbow only offers these tutoring lessons for maths, right? That is the only subject we teach. I'm the only teacher for iRainbow at the moment. Now, Um, we are busy building more and more and more for you guys in the background, and there are more students signing up every day to use iRainbow, right? Because it really is an awesome platform. But we are not able to teach the other subjects just yet because we're waiting to see which subjects we should start teaching first, right? We cannot just go and hire 30 teachers and teach everything in one go. We also want to find the best teachers for each subject. So, um, yes, I do want you guys to please put a message in the comment box if you want lessons for other subjects, right? You could type something like, "Sir, please can we have lessons for English?" Or "Please can we have lessons for natural science?" Right? It doesn't mean that I will be able to teach you those subjects in the next 2 weeks, even in the next month. It's going to take time for us to build up, but the more of you guys that message, um, the more of you guys that message things like that, requests for other subjects into the comment box, the more likely we are to start with those subjects. Okay. I hope that makes a little bit more sense. So I hope that you guys can be patient with us. We are trying to build and grow as quickly as possible, but we also don't want to give you guys a million different options and it's not worth your time or your effort. All right. So again, if you do have a specific question, a request for a specific subject, go ahead and type it into the comment box for me and just say, "Sir, please can we have lessons in this subject?" I then take those messages and speak to all of the wonderful people I work with, and I'll tell them that everyone wants EMS lessons or English lessons. And as people message more and more, we will slowly build our ability to offer those lessons to you guys. All right. So I hope that answers your question. Then just very quickly, someone else has also asked, on a compound shape, can they use centimeters, millimeters, meters on one shape? Guys, no. That's extremely unlikely. Okay, it's not the case that it's impossible, but it's going to make calculations really confusing for you and for your teacher to mark. So when we work on a specific shape, we work with 1 unit of measurement. Okay. So for example, on the shape that I've drawn on the screen here, I have one value that has a centimeter unit on it. That means that all of the other measurements must be in centimeters. Okay, so 99.999% of the time, we are only going to work with 1 unit. Wow, listen to my voice cracking. Sorry, guys. My voice is exhausted after teaching for so long. So this is an example of one compound shape, and now I want to move on to a second one. You guys should already have a rough understanding of what a parallelogram is. Okay, it's a shape that looks like this over here. This is called a parallelogram. For those of you that don't know, a parallelogram is kind of like a rectangle that somebody sat on and now it's kind of skew, right? We call this a parallelogram. Then, if I take the same shape, but I imagine that I started with a square and then somebody sat on my square, I would have something a little bit more like this. When it's a skew square, we call this a rhombus. You guys are going to learn about these shapes in detail if you haven't already. Then lastly, there's one more shape that I want to draw for you guys. It's called a trapezium. Again, someone else has asked if there is algebra ever put into these kinds of shapes. The answer is yes. We do add algebra onto our shapes, so it's very important that we understand our shapes and their properties very well. The final shape that I've drawn over here on the right-hand side, grade 7s, is called a trapezium. Now, like I said to you at the beginning of this lesson, we do not have a formula for the area of every different shape that you can imagine, right? But let's take a look at a parallelogram very quickly. If I copy this picture and I decide to treat it like a compound shape, what ends up happening? Well, I can take a ruler and break it up into pieces, just like I did with my other shapes. So I can draw a perfectly vertical line over here on the left, and I can do the same thing on the right. Okay, the same thing is true of a trapezium. Although it's a little bit of an odd looking shape, we can take a ruler and draw some dotted lines using the corners of the shape to help us create new smaller subshapes. So it doesn't matter if I'm working with a parallelogram or a trapezium. In the left hand case, you can see over here that I have a triangle now on the left hand side and on the right hand side of my shape. And interestingly enough, these triangles are exactly equal in size. The same thing is true of a trapezium, which we have on the left hand side over here. And so even though these are more complicated shapes, they're not super complicated, but we can still see that we land up with two triangles and a rectangle, right? This looks nothing like the shape that we just did. But when we decide to break them down, we can actually follow exactly the same process when it comes to calculating their area. So the last thing I want to do today, guys, in the last 10 minutes is the area of a parallelogram. Now, I do want to point out very quickly that some teachers will give you a formula for this shape because it becomes quite common in high school, right? We love this shape a lot, but we can also, like I've just shown you, break this shape down into multiple pieces. So let's say you were sitting in a test, your teacher gave you the following information. This is going to be example number 2. Right, let's say in this case we are working in millimeters. Even if I only write the unit of measurement once, it applies to all of the values on my shape. So I have 60 millimeters there, and maybe I have 20 millimeters over here. That means it's going to be exactly the same on the opposite side of my shape. Maybe we have 50 millimeters over here and 70 millimeters on the slanted side of this triangle. Let's say you were given this shape. You've never seen it before in class. You've never learned about the formula for the area of a parallelogram. We can still use the information that we're given in this case to calculate its area. This is example number 2. If you have any questions, you know what to do. All right, grade 7s. Let's take a look at this shape. If I want the total area of this parallelogram, right, we use A with a little t under it to represent the total area. That's what this symbol represents. If I'm looking for the total area of my parallelogram, I can break this up into the following. The area of a triangle plus the area of the second triangle plus the area of the rectangle, which is exactly the same as the last compound shape that we did with different measurements. If you guys want, I would strongly suggest you use color, even in your tests and exams, not only in your notes, to help you understand and break pictures up if you can. All right. If you're a bit nervous to do that, you can always use pencil to help you so that you can erase it if you make a mistake. I know that the total area of this parallelogram is going to be these two triangles plus the rectangle in the middle. Now, if you're a little bit unsure, look at the measurements on your triangles. I have a 20, a 50, and a 70. And on the other triangle, I have the same, a 20, a 50, and a 70. If your triangles have the same dimensions, it means that they are going to have the same area. Someone's asked if we're going to do this in high school. You will work with shapes and algebra together in high school, yes, and you'll also work with area in high school. Okay, is it going to be more complicated? I don't know if you mean in this lesson or in high school, but yes, high school will definitely be not more complicated, but it's going to have more parts to it. You're going to have to focus a lot more. Okay, so let's calculate the area of this shape. We've got 8 minutes left, guys, and then we are done for tonight. I need the area of the two triangles plus the area of the rectangle. Before I can go ahead and do that, I've already made a small mistake. Please remember that when you are working with area, you must say that area has the symbol A. Otherwise, the letter A means nothing. Let's go ahead and calculate the area of the triangles first. The area of any triangle is going to be half times base times perpendicular height. If you don't like the dots that I've drawn, you can just replace them with multiplication signs. Remember, they mean the same thing. For these triangles, I have to leave the half as is, but let's go ahead and identify the base very quickly. Let's say we decide to work with the triangle over here on the left-hand side. I can see very clearly that this is the peak of my triangle, and usually opposite the peak, you are going to get your base. So in this case, my base is 20 millimeters. Excuse me, guys, 20 millimeters, right? So let's go down and we can fill our 20 millimeters into the calculation. Now, what is my perpendicular height? It is not the 70 millimeters on the left here. This is our slanted height. Remember, your perpendicular height needs to connect the base of your triangle and the peak of your triangle. And it must form a 90 degrees with the base. Okay, it must make a perfect corner. So that tells us that the height, the height is this 50 millimeters that we see over here, grade 7s. It's not always going to be given to you with a dotted line like this, so be careful. Don't rely on the dotted line to find your height, but we now know that the height is going to be 50 millimeters. When we do this calculation, again, I leave the half as is in front and I start with my values. 20 times 50 is going to give me 1,000. And millimeters times millimeters is going to give me millimeters squared. What is half of 1,000, guys? It's 500. If you wanted to, you could do this sum in your calculator. I simply do it like this to show you guys where the millimeters squared comes from. Okay, when you're done with that, because it's part of your answer, you can just go ahead and underline it so that it's easy to find later on in your question. This is not all that we need though, guys. We also need the area of the rectangle, which is the really easy part. We know that the area of a rectangle is simply the length multiplied by the width. Again, looking at our rectangle over here, it is 60 millimeters long. Please be careful. This extra 20 does not form part of the rectangle, so don't make a mistake and think that it's 80, okay? I know that it sounds silly to point out, but when you get tired, it's easy to make that kind of mistake. Our rectangle is only 60 millimeters long and it's 50 millimeters wide. So over here, we can have our 60 millimeters long multiplied by the 50 millimeters wide. 60 times 50 is going to give us 3,000, and millimeters times millimeters gives us millimeters squared. Right? There we go. Right? This brings us back to the beginning. Okay, just give me a second, please, guys. Right, I'm going to move these calculations up slightly. So we go back to the beginning. We started by saying area is equal to A, and that the total area for the shape is equal to the area of two triangles plus the rectangle. So let's fill in those measurements. We have the measurement or the area value for the two triangles right over here because we've just calculated it. We also have the rectangle. It might not be so easy to spot if you're not using color, which is why your layout is so important. The two triangles are 500 millimeters squared each. And we know that these triangles are the same, so we don't have to calculate separate values for the two triangles because their dimensions are equal. The rectangle was 3,000 millimeters squared. All right, and so when we put this into our calculator to add everything together, we get a final answer of 4,000 square millimeters. That is the total area of a shape that you might not have known before this lesson. If you did, that's great, but you now know how we can find the area of a parallelogram without having to rely on an area formula. Okay. Right, guys. And just like that, we are done with 1 minute to spare. Okay, I'm going to give you guys a second to quickly copy if you'd like to. And I have my eye out for any questions. If any of this has confused you guys, please just take note of how I have 3 distinct sections in my calculation, right? They are not all one massive long line. Instead, I have pieces that are chained together. And this is a dream for a teacher to mark because it's laid out very neatly. It doesn't have to be exactly like mine, but you want to try and keep it as organized as possible. All right. So grade 6s, there we go, guys. That's going to be it for this year when it comes to area. We're not going to spend any more time going through this because I think that you guys should have a pretty good understanding of what area is and how we calculate it by now. This foundation that we've now built on area becomes the basis for our discussion on surface area, okay, which works with 3D shapes. That's the next level of complexity. We're going to touch on it a little bit in next week's lesson, and then you guys are going to use it a whole lot in high school, all the way up until the end of grade 12, and you're going to have to start calculating the area, volume, surface area of all kinds of crazy shapes. Okay. So guys, that's it. You now know how to complete the area of squares. rectangles, triangles, parallelograms, trapeziums, compound shapes. And I think that's quite an achievement. Okay, I hope that you guys can be proud of the understanding that you've developed. I know that there are going to be students at different levels that join these lessons, but I hope that this is really providing you guys with value. I hope that you're learning a lot from these lessons. Maybe you already knew what a parallelogram was. That's great. But maybe I've just shown you how to think about breaking shapes down or how to lay your work out nicely. Not everyone's going to learn the same thing, but all that matters to me is that you guys have learned something valuable in your 1 hour that you've spent with me this week. All right. So grade sixes, that is officially the end of the lesson. Like I said, we're going to have another lesson next week, Wednesday, from 5 o'clock to 6 o'clock in the evening. And we're going to be chatting about volume and surface area, which has got more to do with measurements like this, but it's sort of the next step up. If you guys were new, I hope that you learned something valuable in today's lesson and that you enjoyed it. I hope it's something you'll consider continuing and that you'll be back to join us again next week. Guys, I know we're already over time, but I want to quickly change my screens to quickly show you iRainbow. Okay, if you need to finish copying, I can bring the screen up again just now. Just ask me to do so. But I want to quickly show you a little bit about where to find a quiz on this section of work. Okay, if you guys need to go, I understand you're more than welcome to leave. But if you guys have an extra few minutes, I'd suggest you stick around. When we open iRainbow, guys, yours should look pretty much the same as mine. And we want to start by clicking on the island of measurements at the bottom right over here. And then we will click on measure geometric shapes. Okay. Over here, you can see that we have perimeter, rectangle. So perimeter is its own topic. Then we talk about the area and perimeter of rectangles, rectangles and parallelograms, which we've discussed today. Triangles and trapeziums, we've also discussed, right? And there's more to do with area and perimeter. So all of today's work is not found in one specific quiz, but instead it will be combined in rectangles and parallelograms here on the left and triangles and trapeziums on the right. Okay, we've been through a lot of work today, grade 7s, and I hope that you guys will take a little bit of time to go and practice these on your own. If there's any piece of advice I can give to you, grade 7s, maths is not a spectator sport. You cannot sit and watch me teach and then think you will be good at it too, okay? It does take practice. But the goal of these lessons is to show you how and why we do things so that you can do them on your own, all right? That's why I only do a few examples each lesson. So go and take a look at this section of iRainbow. Go and just potter around, guys. Go and explore. Try the quizzes. See what you're comfortable with and check what you're not so comfortable with, because it'll give you a good idea about what you need to study a little bit more. Okay, but now you guys know where to find it. It's under the island of measurements, the topic of measuring geometric shapes, and then you can select a quiz depending on what you want to test yourself on or what you want to practice. Okay, so grade 7s, now we are officially done, guys. It was a busy lesson, so props to you guys for sticking around. I hope it was worthwhile. If you guys want to copy anything or you have any more questions, you're more than welcome to ask me now quickly. I will stick around for 2 or 3 extra minutes. But for those of you that are done and you understand everything, you guys are more than welcome to leave. I hope that I will see you guys again next week, Wednesday from 5 o'clock to 6 o'clock in the evening. But guys, until then, have a fantastic Thursday and an even better Easter weekend ahead if you're celebrating that. Okay, thank you so much, guys. Have a fantastic evening further, and I will speak to you all again next week. All right. All right, bye, grade sevens. If there's any questions from those of you that are still sticking around, you're more than welcome to ask, and I'll answer them as best I can. Okay, one person has asked, in the test, do we have to state that area is equal to A? Guys, you should. Okay, it's good practice to do that, because if you want to take certain subjects in high school like physics and chemistry, you'll see that we use so many different formulas for so many things, that we have to say A equals this, right? Um, A stands for area here in maths, but it also stands for amperes in physics, right? It can represent a lot of things, which is why we state that. You can check with your teacher though. All right, I would do it because it's a good habit, but some teachers are not so strict on that. So ask your teacher, and you can follow their instructions because they're going to be the ones marking your test, but you definitely won't be marked down if you add it in there. Okay, it's a good habit. Someone's asked if I'm available during the school holidays. To answer that question in short, yes, guys. I will continue with these lessons, the iRainbow tutoring lessons during the school holidays. I do not stop unless there is a very special holiday that's happening. If you're asking about whether I am available to teach you guys personally, one-on-one, that depends. You guys are more than welcome to message me if you would like to and ask about that, but that will then come at an extra charge. Okay, I do personal tutoring, but that's separate from this. If you want to speak to me about it, you're more than welcome to. My number's on the WhatsApp group. But if you are hoping, how do I explain it? These lessons will remain free. If you want private tutoring, then yes, I am available, but it will come at an extra cost. Okay. Any last questions, guys? Is there anything else we want to know? All right. Grade sixes, it looks like that's grade sevens. Sorry, guys, I just taught the grade sixes now. Grade sevens, that looks like it's it for today, guys. I'm not going to stretch the lesson on any longer. We are done for today. Thank you guys for attending. Remember, our next lesson is next week, Wednesday, from 5 o'clock to 6 o'clock in the evening. If you guys have any questions that you think of during the week, write them down, and then you're more than welcome to bring them with you to our next lesson, and I'll try and answer them then. Okay. But guys, thank you so much for attending. It's been great answering your questions and teaching you what I can, but I will speak to you all again next week, Wednesday. Okay. Thank you guys. Have a fantastic evening.